Okay, so now we're gonna do the last example, which is example 9.4 of the course. Okay. It says that a frozen food, ground beef, packaged in low-density polyethylene film has a PCL, which is the practical storage life at various temperatures, as follows, as given in the following table, on different temperatures. And we have the respective different storage values, practical storage life in days. And we said in the previous session the difference between practical storage life and the high quality life. Okay, what is needed from us? From this table, before we go on, we can observe that as the temperature decreases, it goes down, the practical storage life respectively increases. Now, from this table, we have the links in the freezer chain, the average temperature, the storage time in days, the practical storage life in days. You can follow up with me with your PDF. The practical storage life loss percentage per day and the loss percentage, slide 39. We have to calculate the total loss of practical storage life along the freezer chain from processor to consumer, given the time and temperature history shown in the following. And we have to predict, after calculating the total loss of practical storage life along the freezer chain, we have to predict if there is anything that is remaining of the practical storage life and any possibility to be still stored inside the consumer house. And how much is this possibility? How much is the period of time that it's still applicable to be stored inside the consumer house? All of this is from the given out from the table. We're going to derive all the values. Let's start. Okay, I've just written a little bit of the given here. Well, the practical storage life, we have a frozen food, ground beef. It's packed in a low-density polyethylene film. We have to calculate the total loss, as I said, of the practical storage life along the freezer chain from the processor to the consumer. And we have to estimate if there is any left storage time to be stored inside the consumer and that it is still practical to be used. Okay, first of all, I'm gonna start by analyzing the table column by column with you guys, and from here you're gonna interpret with me how we are going to achieve the answer at the end. So let's follow up. By dividing the practical storage life in days, over here 420, we can achieve the product life loss per day as a percentage at the respective temperature. What do I mean by this? Yeah, let's take an example. I have at an average temperature the minus 23 degrees Celsius. I'm gonna write it over here. At minus 23 degrees Celsius temperature, I have the practical storage life in days. Follow up inside the table. It is 420, right? 420 days. At this 420 days practical storage life, this will mean that at this value it will reach 100% loss. Okay? So, per 1 day, what is the respective percentage of loss X? I'm calculating the respective percentage of loss per 1 day at this corresponding temperature. X would be equal to 100 divided by 420. Using the calculator, I will get a value of 0.238%. This is the practical storage life loss per day. Okay, and actually this value is found in column 5. So Column 5, I have over here the value 0.238% per day. So column 5 is representing for me the percentage of practical storage life loss per day. Here I have the practical storage life in general, what is it, and the storage time of these days, okay? Here I have the average temperature. Now, from the storage time of these days, which is represented in column 3, I can get out how much I have percentage of loss till now. Since I know that the percentage of loss per 1 day is 0.238. So then in 40 days, how much do I have a percentage of loss? I'm gonna multiply 40, which is from column 3, times 0.238, which is in column 5, and I'm gonna obtain 9.5% of loss. This is the percentage of loss after storing at 40 days. Okay? And this percentage is actually represented in column 6. As we can see over here. 9.5%. So now we are understanding the different columns. I'm having here the link in the chain, column 1, and at the processor, at the transport, at the wholesale, again at the transport. Then I have the average temperature at each respective chain part, whether we are speaking about the processor, about the transport, about the wholesale. The storage time at these also respective part of the chain, and then the practical storage life in days, the percentage of loss per day, and the percentage of loss according to the time that it is stored inside. Okay? Understood till now? Okay. What we want to calculate is the total loss of practical storage life for the ground beef at the end of the freezer chain. If we go on, the total loss of practical storage life at the end of the freezer chain, we have practical storage life 340 days. And the percentage, the total loss percentage, what we actually want to achieve is 83.6%. It is written inside the table, and it is the addition of the different loss percentage corresponding to each part of the product supply chain, okay, from the beginning till the end to the consumer, according to the respective storage temperature and according to the respective storage time. So the loss is determined and variable with the average temperature, with the average storage time. Each part of the supply chain has its own loss percent, and we can calculate it as we said. The storage time in days times the percentage per day, you will obtain the respective values. Then adding these different percentages will lead us to 83.6%, which is the total loss of the practical storage life of the freezer chain of the ground beef that is stored. Okay? Okay. We obtained the first part that is actually given by the table. Now the second part, we need to estimate how much would be still left, okay, after undergoing all these, if also it need to be stored more inside the consumer house. So over here we estimated that it is stored for 50 days inside the consumer house. Let's say that the consumer is not going to consume this ground beef. How much still this ground beef can be stored inside the consumer house from these relative values? What do we do is that we have the total loss percentage is equal to 83.6%, right? So what is left out from the practical storage life is 100 minus 83.6. We will obtain 16.4%. Okay? This means the percentage that could be also left inside the consumer is 16.4%. Let's go on to the consumer. The consumer is storing the ground beef at minus 18 degrees Celsius. I'm going to write down this condition. And I have the percentage per day loss is 0.033 in 1 day. Okay, percentage of loss of practical storage life loss per day, 0.03333 from the table. I've got 16.4% remaining. So how much days I can store them in order to be respectively practical? X would be 16.4 divided by 0.33333, and this would be approximately 49 days. 49 days it could be stored inside the consumer house at minus 18 degrees Celsius without exceeding the practical storage life. That's it.